Hello friends, Mr. Burrell here. We've just started Unit 3. We're talking about polynomial functions. Before we get crazy into all the different things we're going to talk about with polynomial functions, first we're going to review a little bit more. We've reviewed some of the basics about polynomials, some of the terms and definitions, what a polynomial is. Now we're going to talk about adding, subtracting, and multiplying polynomials. This is something you learned in Math 2 and in Math 1, I believe. So this is just going to be a review. Some of you feel really confident about this. Some of you might be really struggling, but we're going to go through and review all of these, adding, subtracting, and multiplying polynomials. Let's see here. So the objectives, what I hope for you to be able to understand by the end of this video, I want you to be able to add and subtract polynomials, adding them together, subtracting them together, and I want you to be able to multiply polynomials. So those are the objectives. Let me go back. That's what I want you to be able to understand by the end of this lesson, at the end of this video. That's how you'll know that you'll be successful with this content here. So I'm talking about adding polynomials. I can only add two monomials or multiple terms together if they are the exact same. If they have the exact same the exact same variable with the exact same exponent, like so, all of these, I can only add or subtract them together, combine them together, if that is the exact same. So in this case, these are two constants. 7 plus 9 is 16. In this case, I have 3x plus negative 7x, which turns into 3x minus 7x. Since I have 3x's and 7x's, I have the exact same variable with the exact same exponent. 3x's minus 7x's is negative 4x's. I'll do one more here. Negative 4x squared plus 8x squared. Both of them have a variable of x, and both of them have an exponent of 2, so I can combine them together. Negative 4x squareds plus 8x squareds. Negative 4 plus 8 is a positive 4x squareds. You can do this one on your own. When I'm subtracting, I'm doing almost the exact same thing I'm doing when I was adding, except now, notice, when I take 7 minus a negative 3, when I subtract a negative, those signs change because negative times a negative is a positive. Minus a minus is a positive. So 7 minus negative 3 turns into 7 plus 3, which is 10. 2x minus a negative 8x is really 2x plus 8x. 2x's plus 8x's is 10x's. 3x squareds minus 2x squareds. 3 minus 2 is 1. 1x squared, just like that. I can write a 1 in front of here or not, doesn't matter. So that's adding and subtracting monomials like that. We're going to combine those into polynomials here in a bit, but that's the basic concept. When I have two terms that have the exact same variable with the exact same exponent, I can combine them together. Now, when I'm multiplying, it's a little bit different. When I'm multiplying monomials like this, 7 times 9, that's just 63. I can multiply those numbers together. That's knowledge that I have up here in my brain. I understand that. Let me move this out of the way real quick. X squared, whoa, let's see. X squared times x to the 7th. When I multiply x, or variables with exponents, x squared times x to the 7th, that's the same as x times x, because x squared is just x times x, times 7 more x's, x times x times x times x times x times x times x, for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So x squared times x to the 7th is x to the 9th. So when I multiply two terms with different exponents like that, like x squared times x to the 7th, those exponents add up. I count those exponents up. So x squared times x to the 7th turns into x to the 9th. 3x to the 5th times 4, I multiply 3 times 4 and get 12, and there's nothing else for x to the 5th to multiply by, so I get 12x to the 5th. 6x cubed times 3x to the 5th, I multiply 6 and 3 together, get 18. And then multiply x cubed and x to the 5th together, that gives me a total of 8 x's that are being multiplied together, so I can write that as x to the 8th. Remind yourself that an exponent is just a way of writing repeated multiplication. An x being multiplied by itself 8 times. Okay, now we're going to apply what we've just talked about with adding and subtracting and multiplying to a series of expressions. So polynomials, a bunch of terms that I'm adding together, how's that going to work? So if I have x cubed minus 2x squared plus 9x plus negative 7x plus 9, two different polynomials that I'm adding together, I'm going to identify first, okay, are there any of these terms that are the same, that have the same variable and the same exponent? Well, first I have some x cubes. Are there any other x cubes anywhere? No. So that's not going to be combined with anything, so I can just leave that as x cubed. Next, I have a negative 2x squared. Are there any other x squareds anywhere? No, there aren't. So I'm just going to leave negative 2x squared as is. Are there any other x's? I have 9 x's here. Are there any other x's? Yes, I have negative 7 x's. So 9x minus 7x is a positive 2x. I can combine those two together into one term, which is 2x. And then lastly, the only thing I have left is this positive 9, so I'll just tack that on there at the end. I added those polynomials together and got x cubed minus 2x squared plus 2x plus 9. Okay, let's do number 3. I have 6x cubed minus 2x squared plus x plus 3 plus negative 4x cubed plus 8x squared minus 5x plus 6. So I'm adding these together, meaning I'm combining all of my like terms. So first, I have 6x cubed. Are there any other x cubes? Yes, I have negative 4x cubes. So 6 of the x cubed minus 4x cubed, 6 minus 4 is 2x cubed. So those are good. Next here, I have a negative 2x squared. Are there any other x squareds? Yes, right here. So negative 2x squareds and positive 8x squareds is 6x squareds, because negative 2 plus 8 is 6. Next, I'm going to look at my x's. I have an x here, and over here I have negative 5 x's. 1x minus 5 x's is negative 4 x's, and x minus 5x is negative 4 x's. And then last of all, I have my constants, or my numbers that are all by themselves. I have 3 and 6. 3 plus 6 is a positive 9. So that right there is my polynomial expression when I add both of those together. I just combined all my like terms, all the terms that had the same variable and the same exponent. So if you need to dwell on that, look at that. You can try this second one for practice there in the middle if you want some additional practice. Next, we're going to subtract polynomials. I'm not going to spend a whole lot of time on this slide because notice that when I subtract polynomials, so on this first example, x cubed minus 4x squared plus 9x minus negative 7x plus 5, this minus is going to distribute to everything inside of this parentheses. So a negative times a negative is a positive. That changes this sign. A negative times a positive is a negative. And then this turns into an addition problem. So the only difference between adding polynomials and subtracting polynomials is this minus when it's in front of these parentheses representing this other polynomial. That subtraction sign is going to change each of these signs. And then I just follow the same patterns I did before and I add those polynomials together. So in this case, I have x cubed minus 4x squared, and then this subtraction sign turned this positive 9x and a positive 7x. Instead of a negative 7x, this is now a positive 7x. So 9x's plus 7x's is 16x's. And then this positive 5 turned into a negative 5, so that I'm going to write as minus 5. X squared minus x cubed minus 4x squared plus 16x minus 5. So if I go down to say number 6, I notice that there's this subtraction sign here. If I want to change that to an addition sign so I can add these together, I have to change the signs of all of the monomials here in this polynomial after that subtraction sign. So this turns to a negative, this turns to a negative, this turns to a positive, this turns into a negative. Now I can combine all of my like terms. 7x cubed minus 9x cubed is negative 2x cubed. Negative 2x squared minus 3x squared is negative 5x squared. 3x plus 7x is 10x. Positive 6 minus 2 is a positive 4. And that would be my simplified polynomial expression. Notice that in all of these polynomials I've been writing them in standard form, with the biggest exponent being at the beginning and the smallest exponent being at the end. So that's adding and subtracting polynomials. Again, hopefully that was just mostly review. Now let's talk about multiplying polynomials. First, we're going to start pretty basic. What happens when I'm multiplying one term, like 8, 3, or 4x squared, by a bunch of terms, by a binomial, a trinomial, or say this polynomial here with 4 terms? How does that work? Well, when I multiply here, whatever's on the outside of the parentheses here, this number needs to be multiplied by everything that's inside the parentheses. That's called the distributive property. I distribute this 8 to every other term that's inside the parentheses. So 8 times by x cubed is 8x cubed. 8 times by negative 4x, 8 times negative 4 is negative 32, and that x comes along for the ride. So my simplified term there is 8x cubed minus 32x. And that's my final answer there. If I were to go backwards here, and we'll talk about this later on in this unit and next unit, if I were to go backwards, that's called factoring. And I'd notice that both of these terms have something in common, this 8, and I'd factor an 8 outside of this parentheses like this. We'll get to that later. Let's skip down to this number 9 right here. I have 4x squared times by 3x cubed plus 6x squared minus 2x plus 5. So since I have 4x squared on the outside and all of those other terms on the inside, I need to multiply 4x squared by every single one of those terms. I need to distribute it throughout the entire polynomial. So 4x squared times 3x cubed, 4 times 3 is 12. X squared times x cubed, that's a total of 5 x's multiplied together, so that's x to the 5th. 4x squared times 6x squared is a positive 24x to the 4th. 4x squared times negative 2x is negative 8x cubed, because there's 2 x's here and 1 x here. And then 4x squared times 5 is a 20x squared. So my simplified polynomial here is 12x to the 5th plus 24x to the 4th minus 8x cubed plus 20x squared. So that's multiplying a monomial by some other polynomial. You can try this one for practice if you would like. Next, we're going to talk about multiplying binomials. This is what we see a lot. We see a lot of binomials being multiplied together and separated out when we're talking about polynomial functions. So I'm going to talk about multiplying binomials with 2 methods. I'm going to talk about the rainbow method, and I'm going to talk about the box method. I've taught both of these ways, and some of you like one, some of you like the other, so I'm going to go over both of them. If I'm going to multiply these 2 binomials using the rainbow method, note first that the whole reason that method works is I need to multiply everything in this parentheses by everything in this parentheses. So this x I need to multiply by x, and I also have to multiply x by negative 4. This 3 I have to multiply by x, and this 3 I have to multiply by negative 4. That's why I call it the rainbow method. Kind of looks like a rainbow. So x times x is x squared. X times negative 4 is negative 4x. 3 times x is positive 3x. 3 times negative 4 is negative 12. X squared minus 4x plus 3x minus 12. Now, you'll note that these 2 terms in the middle are like terms. They both have the same variable here with the same exponent, so I can combine those together to give me x squared minus x, negative 4x plus 3x, that's a negative 1x or negative x, minus 12. So my simplified expression there is x squared minus x minus 12. We're going to become really familiar with this stage right here, this situation here in the coming lessons. Let's skip to number 12. I'm going to go ahead and solve this one using the box method. This is another method that can help you to make sure that you multiply everything in the first parentheses by everything in the second parentheses. So along the top, I'm going to write 7x cubed minus 3x, this first binomial. Along the side, I'm going to write x squared plus 9. And then each row and each column that correspond with one of these boxes, I'm going to need to multiply those 2 terms together. So this box right here, I'm going to multiply 7x cubed times x squared, which is 7x to the 5th. There's a total of 5 x's here. Negative 3x times x squared is negative 3x cubed. 1x times 2 more x's is a total of 3 x's that are multiplied. Down here, 7x cubed times 9 is 63x cubed. And then 9 times negative 3x is negative 27x. So, now I'm going to ask myself, when I add all these together, are there any like terms? And indeed, in this case, there are. So I can combine 63x cubed and negative 3x cubed to give me 7x to the 5th plus 60x cubed, because 63 minus 3 is 60, minus 27x, and that would be my final answer. So again, when I'm multiplying binomials, you can use these methods here. But really, what I'm doing is multiplying everything in the first parentheses, every term, and multiplying it by every corresponding term in the second parentheses. Okay, we're going to do one of these examples, multiplying a binomial and a trinomial. So this is a little bit more in-depth, few more steps than a binomial and a binomial, but still basically the same concept here. So say number 14, if I wanted to multiply these together, I'll use the rainbow method here. I need to multiply 3x by 2x cubed, by negative 5x, and by 2. And then I need to multiply negative 1 by 2x cubed, by negative 5x, and by 2. So everything in the first parentheses multiplied by everything in the second parentheses. So 3x times 2x cubed is 6x to the 4th. 3x times negative 5x is negative 15x squared. 3x times 2 is 6x. Negative 1 times 2x cubed is negative 2x cubed. Negative 1 times negative 5x is a positive 5x. Negative 1 times 2 is negative 2. So now I have to ask myself, are there any like terms? Well, there's only one set of x to the 4ths, one set of x cubes, one set of x squareds, but there are this 6x and this 5x, so I can combine those together. So I'll write this answer as 6x to the 4th, and then I want to write this term next, negative 2x cubed, because I want to write them in standard form, so that's the next biggest exponent, minus 15x squared, and then 6x plus 5x, that's 11x, minus 2. So that's my simplified polynomial there. Okay, you can try these other ones on for size if you want some additional practice. The last problem we're going to do is multiplying trinomials. So I'm going to use the box method on this one, because I like the box method as these polynomials get bigger. I'm going to make a 3 by 3 box, because there's 3 terms here, 3 terms here. Along the top, I'm going to write x squared minus 5x plus 4. And along the side, I'm going to write 3x squared minus 2x minus 2. So, same principle applies. Each one of these boxes is going to correspond with a column and a row where you multiply those corresponding columns and rows together. So x squared times 3x squared is 3x to the 4th. There's 4 total x's. This ends up being negative 15x cubed. This ends up being a positive 12x squared. This ends up being negative 2x cubed plus 10x squared minus 8x. X squared times negative 2 is negative 2x squared. Negative 5x times negative 2 is a positive 10x. Negative 2 times 4 is negative 8. Whoa, there's a lot going on. That was a lot of multiplication, but notice only difference between some of the previous polynomials that we multiplied together is now there's 9 terms. Notice that these two right here are like terms that you can combine together. All of these right here are like terms you can add together. They're all x squareds. And then these two right here you can add together. So that gives my final answer being 3x to the 4th. And then I have negative 17x cubed. Then I have 10 plus 12 is 22. Minus 2 is 20. X squared. 10x minus 8x is a positive, whoops, sorry, go back. is a positive 2x, and then I'm left with negative 8. So a little bit longer process, a little bit more steps, but the same exact steps, the same exact principle as we were doing on all those other problems. Every single one of these terms in the first polynomial needed to be multiplied by every one of these terms in the second polynomial, followed by combining all the like terms that we could. So that's it. That may have seemed like a lot, but all of that was hopefully mostly review. Some of those more intense problems you might not remember as well, but that's okay. As long as you come away from this being able to add and subtract polynomials, knowing how to add and subtract like terms and combine those polynomials together, and how to multiply polynomials. If you can do those things, I will consider it a success, and you can consider yourself a success. Please let me know if you have any questions. I hope that was helpful, and I hope that you enjoyed that as much as I did.